All right, day 14. This was the funnest puzzle yet. I will go through part 1 real quick, just so we can focus on part 2, which was more interesting. We get a bunch of robots. They have position and velocity. We have to parse it. So we want the first 4 numbers. We can use regex. We need to include possible minus sign, the negative sign. I've added CGMath, itertools, and regex, and defined the vec2 as a vector2 isize. So we need to map all of the lines to robots. Lines map line, and then we want to create a regex on this. Get the first capture, line, and then we want to return the robot, which will be a position. So that will be the first capture and the second capture. And then the velocity. And then we collect it. All right, so now we have a bunch of robots with position and velocity. We now need to find out where they are in 100 seconds. So we can just shadow this. Data would be data, iterate over it, map each robot, and then we want the position to be robot position plus the robot velocity times 100. And then we need to wrap it around like a snake, and you can't use modulus because we have negative numbers. You can use something, a function called rem Euclid instead. We're gonna return px rem Euclid with and y height, and collect that. All right. Oh, I haven't defined. With 1 height 103. All right. Now we need to just count how many are in each quadrant. So how many are here, there, and remove everyone that is in the middle. We'll use filter map. No. Yes. Let data, and we're gonna just select the ID of which quadrant they are in. So iter. What is the difference between filter map and flat map? That's basically the same thing, right? Get the position. So if p.x is is width divided by 2, or p.y is equal to height divided by 2, then we want to return none. Otherwise, we want to check if p.x is less than width divided by 2, and if p.y is less than height divided by 2, then we can call this id 0, and then else sum 1, and then else, and copy paste this 3 4, and then collect that. So then we have just 0, 1, 2, or 3. So we can just count and do data iterate filter on I, and then check if I is 0, and then count that and multiply that. One, 2, 3. And this needs to be dereferenced. And then just print R. We get two, three. Two, 48, and that is the correct. Right. So now the really fun puzzle. We want to know how many seconds until it will display a Christmas tree. And what does a Christmas tree look like? It's not specified. So I'll remove the things we don't need. We can keep this for reference so we can copy it. So we want to move these robots every second, and then maybe check if it's a Christmas tree or not, and then the answer is how many seconds has passed. So first thing we need to do is to actually print the grid. So we have a bunch of robots. We can call them robots instead. And we want to print them. So on Linux, you can clear the command by doing clear status unwrap. I'm not sure if this will work on Mac or Windows. So when we have cleared it, we can just go through the width and height of the Christmas tree, and then print a robot where there is a robot. So for Y in 0 to height, so each row, then we can create a string, so just the characters, or row string as a string, and we want to map 0 to width, and then map the X position. So we want to find a robot. So if there is a robot, we'll print an R, and if it's not, we'll print a dot. So if data iterate filter, and we call this robots now, filter r.x equal to x, and r.y is equal to y. Any. Any. Then we map it to R. Otherwise, we'll map it to a dot. And it is right. We need to collect this into a string as well. So then we can, if we did the last thing where we printed after 100 seconds, then we could do print grid on the data here. So if we'll do a clear and then cargo run, right? So then we get the robots. Then we need. This doesn't look like a Christmas tree, so we should loop and check each second. So loop, and then instead of times 100, we'll do times I here instead. So how many seconds? We'll do a print grid, and then we can sleep for some time. So thread sleep duration, we can do from milliseconds and do 100 milliseconds. And we can also print the number of seconds that has passed. So we'll do cargo run again. So we need to increase I by 1 also. All right. And you can look through this, and I did. I looked through like 1,000 iterations before I gave up and needed a smarter way to find them. So sometimes you can see that things sort of look like a picture, and like there, and the way I figured it was like I counted the number of robots. We have 500 robots in a grid of 101 and 103. So probably if they're gonna draw anything, they have to be like pretty close to each other. And in particular, like either they should have a distance of 1 or the square root of 2. So if we get this like 1 in x and 1 in y. So if we just print that, so we can do if grid, iterate over that, and then do tuple tuple combinations, and then filter out the ones that are really far away from each other. So a minus b dot magnitude, right, so I'll figure that out. Magnitude squared is less or equal to, well, it's either 1 or 2, I think. So let magnitude be that, and we want to return if m is 1 or m is 2. Then those robots are probably drawing something. And then we can count this. So if this is like more than 10, then we'll draw. Right, and then we'll try again. And this is way too many, so maybe 100 instead. Still, but we have still filtered out a lot, so maybe 1,000. Maybe we need to run this in release. All right, so then we don't get anything. 500 maybe. Oh, oop. So I'll do a longer wait. And there we have it. After 7,500 seconds, this is the Christmas tree. So yeah, I think funnest puzzle any advent of code any day so far. So yeah, this took me well over an hour to find.